So how do we decide whether or not a function is even or odd so that we can decide which terms are going to go away in the Fourier analysis? So here are the conditions, if you remember from algebra, here are the conditions for even and odd, or for odd and even, the way that I've written them. F of negative x has to be equal to negative f of x to be odd, and that's for all x values. So look at this one here. So pick an x value, let's say 0.5. So if this whole distance is 1 from here to here is 1, then if we're picking an x of 0.5, x is equal to 0.5. The magnitude of the number is 0.5. So f of negative 0.5 means you come right here, and then you drop down to the function, and so that's a negative function value. And then you take that number is 0.5, and you come out here. Now we need to do f of x. You come out here, 0.5, you come up, you have a positive function value, but then you have to multiply times this negative, so you get a negative number. So you have this negative number is equal to this negative number on this other side. So even though the function value is positive, when you multiply that times that negative, it comes back down here, and so those are equal. So this is an odd function, right? And you can show that's true for all x in this function that I've drawn there. Okay, for even, and I've erased some of my f's here. For an even function, f of negative x is equal to f of x. Here's an example. Don't put this aside for a moment. X squared. So f of negative 2, negative 2 squared, negative 2 times negative 2 is positive 4. F of 2 squared is 4. So f of negative 2 gives 4, and f of 2 gives 4. So that is an even function. So let's, again, pick a number. Pick negative 0.5, just like before. So we come out. So, well, no, not negative 0.5. Pick a positive number. That's the key to the thing, to not get confused. So 0.5. So we come out here, but if we're picking the magnitude of x to be 0.5, then it's negative of that number. So we're coming over negative 0.5, right? And so that gives a positive function value. And then the magnitude of the number x is 0.5. So we come over 0.5, and then we come up to the function. It's a positive function value. And they're the same. Being left-handed is a curse. Okay, so we see that this satisfies the even condition for all x. So this one here is odd. This one is even. Now again, I only did this for 2x values. You need to do it for more, but we can see, you could go through and do this process for other x values, and you would see that that was true for all the other x values. Okay, what about this one? This is the graph y is equal to e to the minus x. Now, real quick, let me back up. If this is odd, so if you want to use, which Fourier terms are you going to use? Well, odd functions, you model odd functions with odd functions. So you would use these terms. And you would not have any of these terms. You also would not have this, by the way. So these terms, this term and this term, these terms, because of the sum, are used to model even functions. And this term right here, well, these terms, because it's a sum, these sinusoidal terms are used to model the odd functions. Okay, what about e to the minus x? So for this one, it would be this. You would use the sine terms. For this even one, you would use this and this. Okay, what about this e to the minus x? This one is neither odd nor even. It's neither. So this one's neither. Because look, if you pick a value, 0.5. Come out 0.5. Well, you know, f of negative 0.5, you want to do this part first, because this is the condition always to start with, and then you look at these other values after you look at this first. So come out negative 0.5, and there's the function value. Then come over positive 0.5, and there's the function value. The magnitudes of those function values are definitely not the same. Doesn't matter what the signs they are, the signs are, the magnitudes are the same. So they definitely cannot be the same as this. So this thing is neither odd nor even. So this is neither. So this is just one example where you would need to use the whole enchilada. Good luck if you get that on an exam. And it's not likely, as we discussed previously, it's more likely that you'll get an odd or an even function where there'll be some stuff canceling to make it easy on you. Okay, a little bit line yop. What about a function that is both odd and even? Can you think of one? That's a difficult one. That's a tough one. So what about this? I'm going to write it down analytically. What about f of x is equal to 0 for all x? Okay? Because look, let's use our test. So if f of x is equal to 0, that means it's the line that runs along the x-axis. This is the function. It's a line. It's a constant value, 0. So if you pick negative 0.5 for x, right, then this is 0. F of 0.5, this is 0, 0 equals 0. So it's odd, satisfies the odd condition for all x. What about this one? F of negative 0.5, 0. F of 0.5, 0. Satisfies that condition. This one's both. And I would challenge you to find one that is not both. And if you get it, you can post it on the website. Post it in the comments page. So this one is both. To be honest, I don't think you should waste your time. I don't think there's another one that satisfies both. I think that's the only one that is both odd and even, is that one. So, okay, that is it for even and odd functions and deciding which Fourier analysis, which Fourier terms to use. I'm going to step out to the side and give you a clear screenshot.